We are now going to look at the RTE on a running system. If you remember chapter B about the HP1000M and the RTE executive system and the missing features, they are not missing anymore. Look here. I will not go through the detailed points in the list. I will do it by demonstrating the two very small demo programs I have just written for this purpose. I will edit, compile and link and execute the two small programs, and in connection with that explain how the different facilities in the RTE system was used. The two programs is called TEFAR and TESON. The father TEFAR programs schedules the son TESON. Unlike in the real world, here can be many fathers to the same one son. This is equivalent to having a lot of VDU terminal programs with lots of data input and then schedule the son which store the data into a file system or into a database. So let's go to the terminal and start the two programs. I'm now going to log in on the terminal. So I activate the keyboard. I write my name, my code, and I'm now going to be logged in. The system set up some parameters so I can easily access the directories I normally use. And it also sends some code into the function key you see here below. I have the working directory UFE, and here I have stored the files related to TEFAR and TESON. So let us see if they are there. So I write DLTE wildcard .ftl, and I would like to see when they were created and when they were updated. So you can see they are there. Now I will look a little more on TEFAR, so I write DLTEFAR point a wildcard, and now I'll see when they were updated and when they were accessed. So you see, here it is. You can see there are 5 files related to TEFAR. There's the source file here, the list and the relocatable file produced by the compiler, a loader control file specifying parameters to the loader, and the run program itself, the exec code. So let us try and run TEFAR. Now TEFAR was started, and you can see TEFAR can schedule and pass data to TESON. So if I select BB, I should key in some data, and that buffer will be sent to the son. So I write BB, and I can write in 10 characters and send it to TESON. But I was aborted with a error code SC05, and that is because I have not yet set up the program TESON. But before we go further, let us take a look on the source code for TEFAR. Now I'm going to talk about TEFAR, and I will look at the source code. And to that I will use the editor. So I write edit x TEFAR .ftl. Now the source code is loaded. The editor has many functions. I can look at them by keying in a question mark, and they are here. I will use only a very few. For example, I could list 12 line, LN12, and here they are. I'm now working in character mode, but I want to work in screen mode, so I write S here. And you see the first page of the program. If I key in Control FF twice, it will quick jump to the next page. If I write Control F only once, it will back up the page. That means if I have made any change on this page, this update will go into the source file. And you can see that it is backing up because the cursor is running down the page, like this. Often, when you look at long source code, it is very convenient to use the function keys down here, so you can concentrate on the code and not about the keyboard. So I use this key here, previous page, so I'm the top of the file. Now we will look at the code. You can see it's a Fortran program and it has code and data separation that is active. We have the program statement here. The name is TEFAR. It is 5 characters and it cannot be more. So it is. It's a disk resident program. It has a priority of 80. If you have any online program to instruments and things like that, it will have a higher priority. Here you have the nice implicit one. That is very nice. That was not in the old Fortran. That means you have to specify the variables you are using so you don't misspell errors. If you forget to do that, you will get a warning or an error from the compiler. Here you have the specification of the variables. Integer 2 is a 16-bit integer. You have some character variables here. A little special down here. This EB buff is equivalent with C buff. And that means that they have the same address. But I can address this buffer both as an integer or as a character variable. And that is nice because the operating system, when you have an exec call, you have to use integer, but you like to operate on the same data as characters. Now we are going to look at the code. The first executable statement is this called rempar with this buffer. This should be the first line in the program, because here we pick up 5 words from the program's ID segment. This is a little buffer in the ID segment which is used for program-to-program communication. You can write into it, read from it with some special call. But the operating system also uses, if a program starts up without any parameters, it put the terminal LU into this word here. So let us see the next page. Here we just put in the program in a name in the variable, resets a little buffer and write all the out what you have seen before. And then here we read 2 characters into this buffer. And let's go to the next page. Here you see we evaluated the keyed in data. If it is a TE, we terminate. If it's an open or close or XX, then we are here. Here we schedule the son with queue and wait. Queue means it go into a queue with other programs which also schedule TESON. Wait means that we have to wait here until the son is going dormant after it has processing the data from this program. When it goes dormant, it passes data back in eBack, and we can then evaluate the data in eBack and see if it is okay. Here, the next line, it is if we have keyed in BB. Let's focus on that. Control T. Here, we put some data into this big buff, some filler characters, and then we read in some character in this buffer. And then we schedule TESON just like before, but one difference here. We pass also a buffer and the length of the buffer. And again, we wait to the TESON go dormant and we evaluate the code in it back. We have this very nice if-then-else structures. So if I have to see what happens next, I have to go to the end if, and I'll just press this next page here. Here I can see I evaluate in it back, and if it is not 0, it is an error. That means the communication has gone totally wrong, or there is something back with TESON. There's also another function. I'll go a little backwards here, and I can see this function here, TSU. Here I suspend this program just for 900 seconds, and I will explain later why. So that was about TEFAR. Now I'm going to talk about the program TESON. So I write edit x TESON here, and we go into screen mode. Here you see the priority is 70, not 80 as from TEFAR. And this is because this program should like simulating a kernel program, and this should have a higher priority than the father. Here we have the nice implicit none, and here's some text of what the program is doing. As you can see, there are 3 functions. It can open itself and initiate. That means in the practical life, it could, for example, open the connection to a database. And then, of course, it could close the connection and shut down. And it could also execute an order, and there could, of course, be several orders. Here, it will just receive a buffer, and it will not store it into a database. It will just print it on the screen. So let us see here, align with this code here. Here you see the definition of the variables. And then we have here the first executable statement in the program. And this must be the first statement to be sure to get the right parameter from the father. Then we look at the first parameter and look, is it at open? And it should be open because the program start up here and it's the first time it should open the database or something like that. And if it is not an open, it's a fatal error, so just terminate. But if it's not a fatal error, we start here, a line here. And here I have written up what the program could do. It will do the things it has to do, and then it should tell the father that everything is okay, and it's doing it by passing some parameters back by this PNT, and then just after you should have the exec call here. This is go dormant with save resources. That means that the program just stops here, it doesn't really terminate. And it will next time it is scheduled by the father or by some other father or by some other program store, it starts here and it look at the information in the little 5-word buffer here, erasing1. So let us start here. Look at that. Yeah, then it can write this code out here, but that is just if you have compiled it with the debug option, which I haven't. So we start here. If the code is BB, then it should get the buffer, and the buffer is stored in SAM. And to get it, it should use this call. But it also has to ensure that there is really a buffer in SAM for this program, and also that this buffer has the right size. So it's calling ABREC. And then it can evaluate ABREC here. And if the AREC is 0, there is a buffer in SAM, and you can check the length of the buffer here. So everything seems to be okay. So I'll just write the buffer here out on the terminal, and then I'm finished. Now is this nice if then else instruction, so we have to go to the end if. So I'll go forward here, that's the end if, and it's just go to 100, and if you go to 100, is passing parameter back, go down save resources as before. The other if then else here, you can see if I get a second open here, I'm afraid I am already program right, I am the TESON, I'm already started. If you get a close order here, it says that's also okay, eBack is set to 0, and then I terminate. But if I get something peculiar order here, I write the received code is unknown. Some idiot must have scheduled me. I don't write that, but it could have been here. So that was about the TESON. I will now make a quick test of TEFAR and TESON. I start with TESON, so I write run TESON, open. TESON is now started up and ready to receive orders. So I start TEFAR. And I want to simulate that I have received buffer from a terminal which I will send to TEFAR, so I choose the code BB and hit return. And I kit in 10 characters and hit return. And you see now the message from TESON, it has received this buffer and also the filler character that TEFAR has put in. So that was a quick test of passing buffers between programs. You can of course also pass buffer from the son to the father. I will do something more. Now I will take the SU order here, suspend this program. Now it is suspended for 900 seconds. But I can go in here and look at the programs now. Here you see which makes this list is of course schedule. The CE is waiting for TEFAR because it has sent TEFAR in the schedule list. TEFAR is time suspended, but notice here, you can see here, it is 4K in the data partition, it is 7K in the code partition, and it is in memory. And it is, notice that, shared. It is a shared program. If you look at TESON, it will also have 4K in the data partition, 7K in the code partition, and it is in memory. Now I off TEFAR. And I look again. Now TEFAR is then not anymore. TESON is there. It's still there and waiting for orders. But now I close it down by writing TESON close. And I have to write TESON close. And if I look now, it's not there anymore. The last order you will give when you close down the application system for all the kernel programs, and TESON is one of these programs. Now I'm going to compile and link TESON and TEFAR. And since I have done it before, I will look in the command stack. So let us see the 4 last lines in the command stack. They are here. I will mark them up and execute them again. So that is done now. Now they are compiled. Now both program compiled and now are linked. And now we link TEFAR and finished. Notice the last line here. The TEFAR is loaded as a shareable program. And how is that done? I will look into the loader specification file by running edit RTE A Features. And here you see the little command file, only a few lines. And the only thing you have to do to make it a shareable program is to make this SP. So easy is it. That was compiling and linking of TEFAR and TESON. We are finished here. A little comment here in the end. Clumsy programming, yes, it is exec code set it to 23 type to 12 HCL call AB reg for testing that the parsing of the buffer is correct. That looks clumsy. But what the programmer, the college seed, for example, for storing a requisition and a results records, that is only this nice little sentence, call requiv and results. And then 2 buffer and an error parameter. The clumsy stuff was hidden embedded, but of course, remember to test the error return. But this facility in the RTE about program-to-program communication, has it really been used in practice? It has. But that is the next chapter.